Hello, this is Hashing and Hash Tables with Connect 4. A hash table is a collection of associated pairs of items where each pair consists of a key and a value. And hashing is how you decide where to put a piece in the table. For now, we will only be using the bottom row where you see hello to represent the table. This is a value, and every value gets a key assigned to it, which is assigned to a spot in the hash table. Hashing, however, has many different methods. These methods are also known as hash functions. The first method, which is the simplest method, is the remainder method. In the remainder method, we take the value and modulus it by the size of the hash table. This will give us our key. 7 modulus 7 is 0. 50 modulus 7 is 1. And 80 modulus 7 is 3. Next is the mid-square method, where we will square the value of the piece and then take the middle number. Use the remainder method on that number and place the piece in its slot. A collision happens when multiple keys need to be in the same slot. A good hashing function minimizes this, but collisions can still happen. Next, we will show you some of the collision resolution methods that handle collisions on the spot. The first method is linear probing. When a new value is placed in the table and the slot it needs has already been filled, linear probing will check each slot one by one until it finds an open slot. There is one problem with linear probing though. Linear probing often leads to clustering, the accumulation of values in one part of a table, but this can be solved by a variation of linear probing. This is called quadratic probing. Quadratic probing skips slots during its search to avoid clustering. Quadratic probing increments by a perfect square. You choose whichever perfect square fits your table. In this case, we chose 2 because our table is small. And as you can see in the table, that has solved the clustering problem. The last method of collision resolution is chaining, which creates a linked list on every slot of the table, allowing multiple values to be at the same slot. But we can show chaining in a better way with a fun game of Connect 4.
Going first with 7, which divided by 0 is the remainder, divided by 7 remainder 7.
I'm going to go with 45, which divided by 7 is 3.
I will go 23, which divided by 7 has a remainder of 2. So I'll put it right here.
Okay, I'm going to go with 67, which when divided by 7 has a remainder of 4.
I will go with 12, which divided by 7 has a remainder of 5.
Going with a 22 divided by 7 gives us a remainder of 1.
On top of you is 8 divided by 7, remainder of 1.
I'm gonna go right above, and 15 divided by 7 gives me a remainder of 1.
58, which divided by 7 is a remainder of 2.
And 65 divided by 7 will give me a remainder of 2.
25, which divided by 7 is 4.
Alright, I'm going to block you off there so you can't get a Connect 4 with a 52, which divided by 7 will give you a remainder of 3.
I'll go on top of my 12 with that 68, which divided by 7 is a remainder of 5.
Now with a 36 divided by 7 gives me a remainder of 1, and that's Connect 4! Let's go! Well, that was Hashing and Hash Tables with Connect 4. I hope you learned something and are ready for that quiz next week, or ready for whatever else you needed this video for. Goodbye.